2, 1, go. Here we go. Hello, Jason Andersen. How are you?
Hey, man. I think it's great. Good week. Sunshine.
Sunshine. How cold is it up there?
It's warmer than average. It's in the 50s today. It's nice. Yes.
Oh, okay.
It's coming. I can feel it in my bones.
Yeah, you embrace that. It's going to be in the 90s down here. I'll take that over the 50s.
Oh.
No, it's nice. It's a dry 90. It's a dry 90. So, yeah. Hey, welcome to our audience. Sorry, we're going to get cut up. Jason and I have been talking. We're just going to keep on chatting. But before we do, welcome to another episode number 4. Square root of 2 is 4. Or 2 squared is 4, sorry. Welcome to another episode of the IT Talk podcast from Our Insights and Strategy, where we talk all things IT. Before we get into our fun chat, have to send out the disclaimer that none of this is to be taken for advice, financial or otherwise. Just listen to what we have to say, sit in amazement at how amazingly brilliant we are, and let it go at that and enjoy the show. All right, so Jason, this week we are talking, what would happen this week? Wasn't there some kind of
some sort of event?
I heard it was an event. It's on
I heard you went to an event.
I did. 3 letters. GTC, that's what it is.
There you go.
Yeah, and it is all about GTC. What a show, man.
There we go.
Before we get into our topics, can I give you a quick rundown?
Let's have it. Yeah.
Really cool. I like what Nvidia did. It's I think Jensen and crew are trying to stay true to their kind of Silicon Valley roots, and they're keeping the event at San Jose Convention Center, which is cool. It has largely outgrown that, but they managed it in a really cool way. Like they had, it felt like kind of Davos meets Woodstock meets Comdex or CES. So they had the main show floor, but then down the street, down Market Street, as you walk away from the conference center, they had these hubs or houses. They had the Lenovo hub, the Dell hub, the all of these different kind of houses, places that like those that you could go into, and they had it set up, and you can meet with them and have drinks or eat food, whatever. I can't remember which one, but one of the vendors actually even had a barber shop open where you could go in and get your hair cut while you're meeting with them. Really cool stuff. And then directly across from the convention center, between Market and I forget what that other street is, there's like a big park there. They turned that into like a festival ground.
Oh, nice.
And they had it was set up with tents, and they had drinks and food trucks, and it was like a party atmosphere. It was really, really, really cool. And then they had the keynote at the SAP Center. But it was a really kind of cool environment. If I had known, I would have planned my my meetings a little bit further apart so I could walk from point A to point B easier.
Yeah. Yeah. I mean, Dreamforce is kind of like that now too.
Is it really?
Where it's got multiple buildings, and you have the courtyard between the Moscone centers, and then some of the sponsors rent the restaurants that are immediately around. It's similar. The problem is it's was it hard? Like, did they put all the analysts in like one sequestered area, or did you get to roam?
So we had our analyst track, right? And they did a good job of you do a few hours with the analysts, and then you get to go do your thing.
Okay.
And then that was Monday and Tuesday, and then Wednesday, it's wide open. You can do whatever you want as an analyst. And I could have stayed an extra day yesterday, but I had to get home. But so they gave you plenty of time to roam and discover, and kind of see what's out there. It's like the supercomputing show, in that you're like walking through a science fiction book that's come to life. It is so cool, man. So cool. Anyway, if you're out there watching and you're thinking about attending next year, make sure you do. It's well worth it. Jensen's keynote is always fun and exciting and good, but just getting on the show floor, what you see, what you hear, what you experience, it's like no other show out there. And I don't mean
Awesome.
that kiss up to NVIDIA. It is. And it is a show that is it feels like less of a vendor show and more of an industry show, which is really cool. So, all right, I'll shut up.
Good.
I'll shut up.
Yeah.
That said, we're going to talk about NVIDIA all day, right? For the next 20 minutes or so. You got something you want to talk about? Something about the expanding software estate? What are we talking about?
Yeah. Well, I think one thing that NVIDIA and a lot of other hardware companies do, right, is they say, well, at our heart, we're really a software company. And what I will say is that some hardware companies say that, and it's kind of marketing. Mm-hmm. NVIDIA really keeps true to it, right? In the sense of, they have open weight models, they have their own enterprise stack. But what was interesting for me to see was this announcement around what they're calling NemoClaw, which is OpenClaw is an open source personal agent that's taking kind of the world by storm. It's actually so popular in China right now that the Chinese government's starting to get worried about it because it's a very powerful local technology that can run on your machine. It can also run LLMs locally on your machine, right? So you get to the point where now all of a sudden the idea of a real personal digital assistant, AI-driven personal assistant becomes a lot more real than what you've seen in the past. Mm-hmm. And like a lot of companies, when they spy upon a nice, cool open source thing, they'll take that and they'll start to add their own value to it, like Nematron models, or they'll optimize it for their desktop cards or their gaming GPUs. And that's what NVIDIA did. So it's kind of if you think about NVIDIA, you think about the gaming stuff on the desktop, and you think about the AI stuff and the models and the stack on the server side. This is really kind of a software product built for their desktop strategy, right? So it kind of is a way to, as you look forward as to what these personal agents can do, and there's, by the way, a ton of them right now. Microsoft just announced Cowork, which is using some Anthropic technology. Anthropic, of course, has Cowork. Perplexity has Computer. Snowflake just announced theirs yesterday. They just dropped theirs yesterday. This idea of being able to kind of join AI in the cloud and the local is going to be a big theme in the next few months. And I think NVIDIA is just getting ahead of it right now. And it's pretty cool stuff. So that's where I kind of talk about how their estate is expanding, right? They're starting to kind of branch out into different aspects of pure play software. The cool part is that you don't need a NVIDIA card to use NemoClaw, but there's a lot of caveats next to that, right? Like you can't run local models, so you have to use a cloud-based model, and who knows what the performance and feature implications are obviously more robust if you go with the NVIDIA hardware. So it's not perfect, but I'll hold that thought for just one more minute. Before I dive into my thoughts on that, but it's pretty cool. It's pretty cool that they're actually doing this, right? That they're making this happen.
Well, let me ask you: do you think so? It is cool that they're doing it. I think the way I kind of have looked at this is, as you kind of look at the way AI is going to mature, right? So right now it's a big cloud play, it's a large company play, hyperscale play, or really large enterprise. Obviously, it's coming to the enterprise, it's coming to the consumer. But when you look at kind of the AI stack, when you look at the silicon aspect of it, the hardware aspect of it, and the silicon, it's easy for that to become commoditized. In fact, if you look at, and this is what NVIDIA is known for, in fact, if you look at kind of an Instinct versus, say, Blackwell or Rubin GPU, the Instinct from AMD, the Instinct actually has better hardware specs than, architecturally, it has better specs than what NVIDIA is doing.
Yep.
It's all in the software, right? So to what you're saying, what NVIDIA is doing is saying, look, all of this underlying stuff, all this underlying silicon and goodness in architecture, it's only as good as the software that runs on top of it. And they're fully optimizing every single core, every tensor core, every shader, every bit of memory is being fully optimized by that software to make it more performant even though on paper you go, well, maybe it shouldn't. It's kind of like looking at a MacBook versus a Windows laptop, right? On paper,
Yeah.
the laptop is much more performant, but the way it's been integrated from silicon up through the OS, the Mac just outperforms it all the time.
Yeah, but I guess it's really kind of always been that way. I mean, even if you look at like Red Hat, right? If you go to Red Hat Summit, which will be in May, right? The big event that they're hosting, I guess this year, and it's Atlanta.
Yeah.
Historically, the most popular session at Summit is the performance tuning session. It used to be run by a guy named John Shack Stober. Everybody called him Shack. He recently retired. He's a great guy. I used to work with him. But Shack used to get like keynote level attendance for his performance thing. And even Red Hat, had to kind of pick where they were going to optimize and what they were going to optimize upon. So, one of the things that people keyed in on was, okay, when Red Hat builds out their optimizations and does their testing, what are they actually testing upon? Because that was kind of a signal that that's going to be where it runs best, right? Because right. And, even if you look at proprietary hardware like, routers, right? I mean, the software. So, I mean, there is this aspect to it where if you build software optimized to one platform, you're going to get the best result. That's true, right? It doesn't matter what, if it's an operating system, if it's an app, whatever, that's the case. But, is that a real reflection of reality, right? And that's not what really happens in the real world. So that's where it gets a little wacky, right? And that's why, I wrote a piece on OpenClaw a couple weeks ago, and I basically said the open source version is kind of scary to enterprise, right? Maybe you should wait. And then within 2 weeks, because everything's at AI pace, 2 weeks later, all of a sudden, all these companies like, well, I have my own variant or I have something like it. And that should be enterprise ready because it has my name on it. And the question is that, well, sure, that's a step forward. That's a big step forward, but it's not it doesn't necessarily mean you need to buy it and deploy it now, right? It's worth testing. It's worth trying out to see. Yeah. I got into a back and forth with a very good friend of mine who also is an NVIDIA employee who was making his case. I was like, well, I'm not even really sure what the best use cases are for this. And he was like, well, what about this? And what about this? And my answer was, those are just glue for bad software integration at the enterprise. I mean, basically I'm going to use an AI to piece together these disparate pieces of software that don't talk to each other. Well, you can make those things talk to each other on the back end at a much lower price than running inferencing against it all the time. Sure. So, you got to, this one, it looks super cool and it sounds super cool, but it just feels like it's not quite there yet. Like the idea is there, but is there enough best practice to it yet? And the answer is, I don't think so.
Can't you say that about AI writ large? I mean, it's from an enterprise perspective.
I don't know.
Don't
not all of it.
Don't be silly. Of course you can. If I am a commercial enterprise, there is no way I go into saying I'm going to deploy this thing commercial enterprise. Okay.
Yeah.
There are two ways to look at this. There are the folks that go into Red Hat tuning sessions and go, what hardware is that running on? And I fill up. But the people attending those sessions are people that are so far along.
Right.
Right. So for the average person out there and the average company out there that does not have a team of data scientists, a team of hardware engineers that fully understand this, AI is not ready for them. They're not ready for AI yet because the tools in the platform.
Except for the developers. If you go talk to the developers now, they're all using it.
Again, define developer, because
guys who write code for a living, they're all using it.
Hold on. Even that, there is a big spectrum of capability of these folks, right?
Yeah, and how they're using AI varies. I'll grant you that.
That's my point here. When you look at that commercial enterprise that has 2,000 servers, a few thousand employees, and a team of IT folks, they ain't ready for AI yet, and the tooling isn't there for them yet. And this is, I think, what NVIDIA, everything is NVIDIA is trying to do is aimed toward that horizon point where it becomes, they build all of that tooling and abstract all of that complexity, and eventually it becomes very consumable to everybody, not just, and that's what all the software companies want to do, right?
Oh yeah.
They're not there yet. Nobody, I don't think anybody is there yet, which is why it's only being deployed by the big companies.
Yeah, and I don't think anybody's fully there yet. I'll grant you that. I mean, I do a lot of research for a lot of different profiled companies, and they all have gaps, right? Some do some things better, some things nobody's doing it all well yet.
Yeah.
I think there's some people who lead a little bit more on the enterprise, the IDIs, the non-functional requirements that do that better. And then there's other folks who lean more towards the functional user side, and they do a lot better job there. And that's kind of been the friction, right? Because those two aren't the same companies all the time.
Yeah.
So there's a lot that's still getting, it's still pretty young. And I think this desktop side of things is even younger, right? And I think that's really where it was kind of news grabbing. Just to shift gears, because I want to keep the time, is also the flip side, though, of the software estate was Omniverse, right? And I think that what's really super interesting, and I was at the Synopsys show last week, and Synopsys was one of the first partners to raise their hand and say, we're using this technology for our simulation and digital twins, and running on top of Omniverse. They announced that. That was a cool announcement at the show, but then NVIDIA shows up with a bunch more partners in addition to Synopsys. This to me is a big fundamental shift. It's massive because the cost of prototyping has gotten so high, and the cost of invention has gotten so high that having the ability to build early prototyping, even if it's not late stage prototyping, but be able to take over the broad pyramid at the bottom of prototyping, ideation, and simulation, that's going to be huge for companies, because then they'll be able to prototype much more effectively. I see that bringing products to market faster. So I think that while I'm a little bit on the desktop stuff, I was like, Omniverse, I went, wow, this is a big deal. And, you've got some big clients using it. And I do think it's going to have a big impact in the future. And you're going to start to see, more AI in the physical world because of it. It's just going to happen because you'll be able to train the knowledge or train intelligence into a device, and that device will be able to do it, which is what we saw with the robot.
Yeah. Well, I'll tell you what, man. I'll tell you to what you're talking about, and this again speaks to something. I'll flip back to this. Speaks to something I think NVIDIA is doing quite well, and I wonder a little bit with AMD when I think about it, and that is, you've got to. There are two ways to go about kind of enabling AI at scale across the enterprise, whether it's physical, whether it's agentic, whether it's regardless, right? Whether it's personal. There is rely on the ecosystem to provide the tooling and all of that, and just kind of throw your silicon out there and your platforms out there and let everybody figure it out and build some tooling around it and build the solutions around it. Or you hold their hand and you make it a very tightly integrated and easy to adopt solution from enterprise users and consumers. NVIDIA with Dynamo, NVIDIA with Omniverse, NVIDIA with everything they're doing around in the SOC, with NIMS, with NeMo, with NeMo Cloud, everything they're doing is geared at making the adoption of their parts a whole lot easier for people. AMD's tact has been, we're going to build really good hardware and work with open source partners to do it, which will attract some of the Red Hat folks, but it won't attract the masses. And I think there's got to be a more concerted effort from AMD if they want to be more competitive there.
So I won't say the client's name, but I'm working on a significant piece of client research right now. And the interesting thing is that when you talk, that's the topic they want to talk to me about, right? That's what we're working on with them. And what I'll say is this, is that one of the conclusions I've reached is that if you look at the two cases so far with AI and generative AI specifically that are taking hold, there's the developer side and then there's customer service. Those are two areas that are getting really good traction, right?
Yeah.
And people go, okay, well, that's interesting. If you look at the profile of users for those spaces, you couldn't pick two more opposite groups of people.
Right. Yeah.
right? And that's really interesting because, usually what you try to do is you try to pick a target, and then you pick the thing next to the target, and you pick the adjacencies, and you kind of build a concentric circle of adoption around that, right? That's kind of the classic method, right? This is like two completely different worlds. So when you go, well, geez, we want to be, I'm a big vendor, I want to be your AI partner. The breadth upon which you have to do that to win that kind of trophy, so to speak, or win that type of revenue is huge, because you have to solve for people who really want structure, and they need their hand held, and they need to be brought through the journey. And that's your customer service people. That's like marketing folks, and then there's the people who are like, hey, you know what? I need to move fast. I hate structure, and I'm going to go find my own tools and figure it out. It's kind of like the rebels and the apple polishers, right? Yeah. And, so how do you deliver solutions for all of them? And to your point, I think that Nvidia happens to be one of the companies on the software side that is doing a good job of that. Not everybody's doing that as well as they are, for sure.
Yeah. We could talk about this one all day long.
Yeah, forever. We can go forever. Yeah.
All right, I'm going to go really quickly. We're going to shift gears, and we actually are going to talk about hardware.
Yes, this is a good one.
All right, so here's the setup, okay? And you can agree or disagree, but and I like the story NVIDIA is doing. So I'm going to back up. Last week, there was a big announcement, and I covered it on a different podcast, between AWS and Cerebras to talk about this thing called disaggregated inference. And what the hell is disaggregated inference? So people think of AI and they think of training, and they think of inference, and those are two kinds of workloads. I'm sorry, my phone will not stop.
So popular today, Matthew.
That's spam. That is spam. Posted directly to voicemail. Damn you. People think of those as two different distinct workloads that kind of work together, right? Actually, you can break up inference into two sub workloads as well, or two workloads that work together as well. You know this, but for the folks listening, think of inference as what they call pre-code and defill. So pre-code is Jason enters a prompt into ChatGPT. What does this thing mean? I have these, I have all this stuff I've looked at. I'm going to upload it for you to kind of make sense of it all for me. And so chat goes back, and it does its research, it scans the web, it grabs all this information. That is the decode phase, where you're setting context for an answer. Prefill is chat saying, okay, I know what I want to tell Jason. Let me start generating the answer. And it comes out tokens, and you can see it sometimes on your screen when you see it populating words across your screen, left to right, like almost like an old terminal. That's called prefill. Token generation. Those are two distinct workloads. One is highly parallelized, which is the decode. One is highly serialized, which is prefill.
Yep.
Those have different performance characteristics. As I said, parallelized, serialized needs a lot of memory bandwidth, needs a lot of memory throughput. And so HBM and SRAM, two different kind of types of memory. And so people have been trying to solve this inference with GPUs and say, hey, whatever you've been using for training, just use it for your inference and you're going to be just fine.
Right.
That's not true. And so Cerebras was a company that AWS partnered with to kind of do this. Cerebras has that big wafer scale system that has a whole bunch of SRAM, a whole bunch of cores to make that serialized function super, super fast. And NVIDIA, a few months ago, went out and bought this company called Grok that's been around forever. And people for a long time were like, what is this Grok thing and what does it do? And because they've been around for quite a while. And how does it fit in the AI space? NVIDIA unveiled its plans this week with this disaggregated inference play. It's called the Grok. Oh, what is it? It's called the Grok. Make sure I have it right. It's the Grok 3 LPX rack. So it's a rack full of Groks that sits across Vera Rubin environments and that decode function for inference. And so you go and you enter a query, and your Rubin GPU is going to do all of your pre-fill for you all the context setting, and Grok is going to feed you your information to make it that much faster. This is one of those inference at scales. When going back to what we were talking about, I'm a really big organization that is really far along the AI path, and performance is everything. This is what drives your performance out and gives you that best-in-class inference performance. What I want to see, and this talks to something a little bit bigger, is, and that's a really cool story. I love it. Oh, by the way, the tie-in for agentic is when you start using agents at scale, you have one agent that talks to 20 agents that talks to another 20 agents, and all of a sudden those context windows get really, really big, and they outgrow. And by the way, there's a KV cache element to this, which we won't get into. But you need that larger footprint to start feeding this beast, and that is what Vera Rubin along with Grok is going to provide. Really cool story. Really, really cool story.
Well, I mean, it's an FEP. I mean, let's put on our old mainframe hats, right? It's an FEP, right? It's front end processing. It's a concept that we've had for 60 years, right? Yeah. So, it's cool. It's cool to do it in an AI sense, but it's funny how it's being positioned as revolutionary. That's all.
But you know what I find interesting about all this is and this speaks to, and going back to what we were talking about earlier, this speaks to how early we are in the AI game. It's like, okay, well, we uncovered the bottleneck. And I'm like, no, you uncovered a bottleneck, because what's going to happen.
True.
Yeah, there's going to be more and more bottlenecks as you go from model to user. Yeah. Go ahead.
And agent software isn't that smart yet, right? Huh. It's not, there's no element of self-direction in agentic right now. I mean, so it might know the next thing to do, but it doesn't know why. So in that case, if you're throwing, to your point, if you're throwing something to an agent and it's on the front end and it needs to be passed to the back end, the orchestration isn't there yet. And there's even still a debate as to should the orchestration be in the agent or outside. And you start to get to some really disaggregated use cases, and this thing becomes a lot more complicated really fast, right? So super cool. I think Nvidia was brilliant to come to terms with the fact that the GPU isn't the answer for everything. I think that was smart on their end, because they are seeing real competition from other form factors, right? There's a whole slew of inference specific technology out there in Silicon Valley right now, but also, you also have TPUs out there. You're doing things with FPGAs and ASICs now that couldn't be done before, and that's getting, that's part of the AMD game, right? So, there's some. They were smart to get ahead of this, and Amazon is equally smart to kind of push it. They're doing it with a partnership, which is fine. But yeah, I think this is going to be a big deal for the hyperscalers, right? And in a way, it's kind of similar to this. It is kind of tied to this story about disaggregating a certain amount to local compute too, with the Nemo Cloud. Kind of that's been this, not to go way off tangent here, but that's been one of the cooler parts of this AI thing. Is like, it used to be like development tools were like, they didn't connect to each other, right? You had like, I have a no code tool, I have a pro code tool, they don't talk to each other. Now you're starting to see this stacking of the tooling. So the pro code guy writes some code and then it can be used by the low code, no code guy, right? Or gal, right? Yeah. Now you're starting to see this kind of disaggregation on the hardware side as well. And I think that is one of the cool parts of this AI movement, has been this kind of a move towards more verticalized stacks versus horizontal. And I think in the long run, that pays off for the customer, right? Because they'll get more reuse, they'll get more stuff. The other thing is, quite frankly, for years, I've been wondering, and I think you've been wondering, it's like, well, once we train all these models and we have a model consolidation, what does happen to all these GPUs? Well, Omniverse just helped us answer that. Oh, yeah. That's you got an old GPU, maybe you want to start doing simulations and digital twins on it.
Yeah. Oh yeah.
That H100 that's hanging around. You got a use case for it, right?
There's a lot of utility for them. Yeah, it's interesting to me. You said something in there that's interesting too, and that is kind of talking about the hyperscalers and at scale. What I want to see is, I'm waiting for a vendor to start this conversation. It goes back to something earlier, and that is, I haven't heard a single story or a single presentation that says you enterprise organization with 1,000 servers and 5,000 employees, this is how you deploy AI. You're not doing a Vera Rubin 72 with
No.
the rack alongside it with Bluefield DPUs. You're not doing Helios from AMD. You're not doing that. It's not an AI factory. It's an AI foundry. It's a smaller version.
Yep.
You know, I want, and by the way, and here, going back to the software, here's all the tooling around it to make it really simple for you. You are not going to waste your breath explaining disaggregated inference to a commercial enterprise CIO. You're just going to tell them how it's faster and how it's better than the other solution. With, you know, it's enabled in the stack, but you're not explaining this to them. They don't even care.
Right.
I'm going to make this a really consumable solution. It would be really great if a Dell, a Lenovo, an HPE, somebody started talking to that audience, because the horizon might be 3 to 4 years before they adopt, but the horizon is coming, and whoever establishes a position as the leader in that space is going to reap the rewards, and they're going to be bigger than the hyperscale rewards they're reaping today.
But let me ask a different question on that. Does it have to? You brought up 3 of the biggest server companies, right? Does it have to be a server company?
No.
Right. I mean, that could be Microsoft, right?
I still think that, though, that there's some on-prem element to all of this that is going to have to be served, and it could be a Microsoft branded rack that goes into
right. There has to be physical plant. I'm not arguing that point. I think the point is that the lines are blurring so much between these companies now. And by the way, you know, Microsoft does make some hardware, right? Or they deliver it. So there's no reason why. Or they could do a Nutanix type of play, right? Or even Nutanix could do this, where they could go, you know what, I'm going to build the template, but I'm going to farm out the hardware work to Dell, Lenovo, or whoever. So maybe those big players and servers are still there, but it's still a Nutanix-like solution, right? With the template and the software. I mean, that's what Broadcom ultimately does.
Without it, I mean, IBM is actually, strangely enough, IBM has a solution called Fusion, which kind of speaks directly to this.
Yes.
And by the way, it uses Dell or Lenovo servers as the compute engines for this integrated solution, right? It's IBM storage, it's Dell or IBM or Dell or Lenovo compute.
Yeah, and sovereignty is going to be what helps. It's going to be funny, because it's not going to be the gee whiz technology. I actually think the forcing function for CIO is going to be sovereignty.
Yeah,
it's very easy. It's very easy to point to a rack or a set of racks in a data center and go, "It's there."
Yeah. Oh, without a doubt. Yeah. I don't think the end state is an all cloud play. It's not an all on-prem play. I think it's a federated cloud neo-cloud. I think there's a huge neo-cloud here and on-prem.
But that does bring me to the point where I brought it up. You kind of tickled me there, Matt, which was, as much as we like this NVIDIA software stuff, I just have such, like, hardware companies can't sell software, man. It's just such a different model. It's just such a different sales process. The marketing's different. I mean, it's so hard. And to your point, consumability is software's job. So I think it is funny, because as much as I respect what NVIDIA's done, are they going to be like Intel, which is, hey, we're going to invent all this cool software that shows the customer the way, but ultimately the customer buys some other software stack, right? Which is kind of what happened to Intel, right? Yeah. And that's probably why AMD is avoiding the same fate, right? So I do have to wonder about that.
I don't necessarily think NVIDIA has to develop the software that is consumed, but it has to build the software that enables the consumption. So you talk about the Nutanix model, right? It might not be on the surface an NVIDIA piece of software, and this is what Intel did a little successfully. Is it's not necessarily the NVIDIA software that a user is interfacing with, but it's the NVIDIA software. It's the glue that is invoking a lot of the hardware interactions.
True,
and I think that is absolutely critical. Whether that's served up by, you mentioned Nutanix, could be them, it could be VMware, Red Hat, whoever that is, or somebody else, right? Is different. But I think there is that that glue that has to be built, that they are doing a very
And to be fair, Intel did that for the kernel, right?
Exactly.
I mean, for the Linux kernel, I mean, they did more lines of code than, well, maybe Red Hat did more lines of code ultimately, but in the beginning, it was Intel who put the most into the Linux kernel.
Yeah. So, anyway, hey, we're coming up on time. Sorry. So what's going on next week for you in the next couple of weeks? It's been we could talk about this stuff all day.
Yeah. So next couple of weeks actually is just, it's good because it's research. I'm prepping. So when we meet again, I'll do one more thing, probably talk a bit more about my research stuff. But then after that, it's 4 to 6 weeks of on the road. So so kind of I got a couple weeks reprieve, which is great. But then then it gets crazy. We got Salesforce, Google, all the shows. I'm going to do an Amazon thing. So yeah. Yep. So a lot coming. kind of like, oh, here comes the storm, right? So
take the rest. Yeah, I'm going to be in San Francisco next week for an ARM event. I'll be back in San Francisco the week after for Oracle and MediaTek, and then I'll be in Chicago for Nutanix, and then a bunch after that. And in that window is Red Sox opening day on March 26th. So
is it March 26th or April 26th? Is it March 26th? Mm-hmm. Wow.
Yep, Cincinnati Reds.
Yeah.
Hey, one last thought. What did you think of the WBC?
Well, there was a big debrief at the house. There's a lot of disappointment because of the Dominicans losing. But what I'll say is, a lot of Red Sox on the Venezuela team.
Yep.
So I was thrilled. I guess what I'd say is, if you look at the semifinals, the 4 teams that should have been there. Right. Yeah. And so, a lot of championship rounds, it's always the semifinal round that seems to be the better game than the finals.
Yeah. Yeah.
I did, like I said, I did enjoy it. It was good. Now we're ready. I like how it's, I guess I'd say is, I kind of like how it's a teaser, it kind of gets you fired up, because baseball is such a long season that, a lot of people don't really think about it until like June 1st. So now that they built some momentum, that's pretty cool. That's pretty neat how they did that. I like it.
It's fun to watch. Venezuela was stacked, man.
Oh yeah.
Right. Wilfred Abreu for, man, I love that kid. Yeah.
Good stuff.
There was a stat I saw. One last thing. There was a stat I saw that showed the whole WC play out, and it showed most home runs. And I think it was Venezuela was first, maybe the DR was second, or maybe that was reversed, and then the USA, and then the Boston Red Sox.
That's cool. It's gonna be fun. It's gonna be, like I said, up here in Boston, the weather's turning nice. So I know my son's got tickets for Patriots Day, so he's psyched. For the Marathon Monday, he's at the game, so that'll be cool. And I'm a little jealous. Yeah. But it's a school thing, so he's going to get to go for school. But yeah, all's well.
All right. Well, listen. Thanks for tuning in. Thanks for everybody. Thanks for everybody out there that's kind of watching from home or the office or whatever. Thanks for chatting, Jason. And we're going to do this again in 2 weeks, 2 whole weeks. So come on back, and we're going to have more to talk about. And until then, you all have a wonderful weekend.